Hello, it's the Math Dog here. This is a video on horizontal translations of linear functions. Should be for, say, 8th grade Algebra 1. Possibly you could go up to Geometry Algebra 2 with this. You should have a pencil, graph paper, and a ruler ready to work the practice that's in this video. This video is not to be shared or reproduced without the written consent of the creator, that's myself, the Math Dog. Let's get started. So the most basic linear function is f of x equals x. Often this is called the parent or parent linear function. F of x equals x is also called the identity function because any point on the function, the input and the output are the same. So for example, this is 5, 5. The input is 5, the output is 5. This is negative 4, 4, which is negative 4 in the coordinate system. So you could make a table here if you like. So for example, if x is negative 3, f of negative 3 is negative 3. So we have the point negative 3, negative 3. If x is negative, say, 1, you have f of negative 1 is negative 1. And by the way, this does not mean multiplication. This means the function evaluated when x is negative 1. This means the function evaluated when x is negative 3. So this gives us the point negative 1, negative 1. If x is 2, we have f of 2 is 2. So we have the point 2, 2. And we could plot these on the graph if we like. So we have negative 1, which would be right here. And we have 2, 2 right here, etc. So this video hopefully will help you understand why horizontal shifts of functions are the opposite of what you might think. For example, the function f of x equals x minus 2, you might think the parent function f of x equals x is shifted 2 units to the left, but in fact it is shifted 2 units to the right. Likewise, f of x equals x plus 9, you might think that it is shifted 9 units to the right, but in fact it is shifted 9 units to the left. So my approach in this video is to hopefully get you to see why this is to the right, and this is to the left, because it's kind of not intuitive why it is, and I hope that you will see that in the problems that follow. So let's start with an example here. So translate f of x equals x 6 units to the right. So the way I'm going to do this is my original coordinate system where 0, 0 is located right here. We're going to create a new coordinate system where this is 0, 0. I'm going to call it capital X, capital Y versus little x, little y, or y equals f of x. So this again is the function f of x equals x. So in the new coordinate system, this is 0, 0. In the old coordinate system, this point is 6, 0. This is where I'm moving my function. I'm moving it 6 units to the right. So I'm taking a point on the origin in this case. I move it 6 units to the right. And I could do that for every point on this function, but I'm going to come up with the rule by just moving this point here. So in terms of big X, what I do is I'm going to look at this right here, and I notice to get from 6 to 0 I have to subtract 6 from little x. Y does not change here, so this stays as little y. Okay, so now I will replace big Y with little y, and I'll replace big X with little x, and this is the equation of the shifted line. Of course, this also could be f of x equal, well, we're not using f of x here, that's the original function. So this is y equals little x minus 6. We could call this function that let me draw that function in now, that's shifted. So it's the identical function, it's just slid 6 units to the right. Identical to the original function, except it slid 6 units to the right. And the graph would look like this. Okay, so this is, in terms of our new coordinate system, this is actually capital Y equals X. In terms of our old coordinate system, it's y equals x minus 6. And let's say this is also, we're going to call this function new function. Give it another name, we'll call it g of x. Well, g of x would be little x minus 6, and you also can see this written as f of x minus 6. That's another way it's sometimes written. And what does that mean? Well, that means everywhere in the original function f of x equals x, I'm going to replace x with x minus 6, so g of x then ends up with what I had before, because if I replace x in the original function with x minus 6, I get this. Okay, I'm going to take the exact same function here, f of x equals x, move it 6 units to the right, but I'm going to actually start, instead of using the point 0, 0 here as my starting point, I'm going to use this point on the graph 3, 3. And this is the only example I'm going to do this in, because otherwise I'm going to be starting from the origin. So in the old coordinate system, this is 3, 3. So I'm moving this point 6 units to the right. And in the old coordinate system, that would be 9x and y 3, or x equals 9, y equals 3. In the new coordinate system, we're going to call this 0, 0 again. Okay, so in terms of what I have defined here, what I do is I look at this, and I know to get the new x, I have to take away 9 from the original x. Y now, I have to take 3 away from y. So I have this. So now big Y is going to be, I'm going to replace it with little y minus 3, and replace big X with x minus 9. Now notice if I rearrange this and solve for y, I get exactly what I had before. So my point of this exercise is to show you can actually start at any point on the function and get the new equation of the translated line, which again is going to be this line right here. It's going to look like this. Okay, so again, everything else is the same as before. G of x could be written as x minus 6. It could also be written as f of x minus 6, which again just becomes x minus 6. So I'm not going to do this again. I'm just showing that you could take any point and apply these rules, and you're going to get the same function. So again, a shift to the right ends up being a minus 6 instead of a plus 6. All right, let's translate the function f of x equals x 4 units to the left. Okay, so I'm going to start at the old origin, 0, 0, and I'm going to move 4 units to the left. So in the old coordinate system, this would be the point -4, 0. In the new one, I'm calling it 0, 0. That's capital X, capital Y for the axes. So this is going to be, again, a slope of 1 like before, because this is f of x equals 1x. So the function will look like this. Okay. All right, there's our new function, which is, again, it's actually, in terms of the new axes, this is y, capital Y equals x, and we're going to figure out what it is in the old axes in just a second. You probably already figured it out, but I'm going to show why it is what it is. So capital X, in terms of this, looking again, I look at these points. To get x, to get 0 from this, I have to add 4 to little x. And to get y, I don't do anything. So it's a capital Y is little y. So now making this substitution, replacing capital Y with little y, replacing big X with little x, I get this. So a shift to the left actually is adding 4, which is kind of, again, counterintuitive to what you would think. So if I call this function here, again, if I call this g of x could be written as x plus 4 but could also be written as f of x plus 4, and everywhere in the original function here replace x with x plus 4, I get g of x. Okay, so this is a practice exercise. Stop the video. So how about your ruler, graph paper, pencil, etc. So I want you to translate the function f of x equals x, that's this, the parent function f of x equals x, 8 units to the right. So I'm assuming that we're going to start here at the original origin 0, 0. I want you to fill in the coordinates in the old system here, then fill in the coordinates of the new system like we've been doing. And this is going to be the new x-axis. This is going to be the new x-axis and the new y-axis, capital X, capital Y. This is the old xy axis here, little x, little y. So go through and do this like I did in the examples. And when you've done that, start the video again and see how you did. Okay, so I've moved the point 8 units. This point has been moved 8 units to the right. So the old should be 8, 0, the coordinates in the old system, and the new coordinates, well, this is my new origin, so that's going to be 0, 0. Okay, to convert from little x to big X, I am going to have to subtract 8 from little x. Notice that y does not change. Y does not change right here, so that's just little y. So now, substituting in here, we'll have little y equals, replace big X with x minus 8. So again, notice that we shifted right, but actually we're subtracting 8 in the equation or function. So now g of x could be written as x minus 8. So I'm assuming this new function is, we'll call it g of x. And I'm going to draw this in here. So this will be g of x. So another way of writing g of x then is f of x minus 8, which again, if I replace x in the function with x minus 8, I get g of x equals x minus 8. Okay? Okay, once again, stop the video. Here's a practice question. Translate f of x equals x 7 units to the left. So here's our, again, our function f of x equals x, or y equals x. This time, here's our original coordinate system. We're moving our new origins. We're moving to here. This is going to be our new origin. So I want you to list the coordinates of this point in terms of the old coordinate system, which is little x, little y, and then the new coordinate system, we're going to assume this is the new origin, capital X, capital Y. So when you're done, start the video and see how you did. Okay, so to go from here to here, the coordinates of this point in the old system would be -7, 0. And in the new coordinate system, this is the new origin, this is 0, 0. So to go now from -7 to 0 for x, I have to add 7 to the little x, because -7 plus 7 is 0. Then here there's no change, so big Y is little y. So now making our substitution, we have little y equals big X, I replace with x plus 7. So there is our equation of our shifted line, which is over here. Let's plot that. Okay. Alright, so this will be, we're also going to we'll call this g of x again. And in terms of the new coordinate system, This is again y equals, capital Y equals x. So now using g of x for our notation, we're going to have g of x is x plus 7, or we could write f of x plus 7. And we could replace then everywhere. What we're doing is we're replacing everywhere in the original function f of x equals x. We're replacing x with x plus 7. So this becomes again x plus 7. G of x equals x plus 7. Okay, now let's say we have instead of x, we have f of x equals 3x, which is a stretch. Instead of a slope of 1, which is 1 over 1 up, we're going 1 over 3 up. So this line is 3 times steeper than what we started with. So, but we're going to still start at the original origin. So we're going to translate this function 5 units to the right. So again, I'm going to move over here 5 units to the right. And in the old coordinate system, this is the point 5, 0. In the new coordinate system, this is going to be my origin 0, 0. So the new function's getting shifted from the old function's getting, we're doing a slide of 5 units. Okay, so I'll keep my new slope, so 1 over 3 up, 1 over 3 up, because the change in y is 3, change in x is 1, that's what the slope means. So let's just get some points to make this easier to graph. Okay, so we have a slope of positive 3 now. And I'm off. I'm off a couple points here, so let's fix that. Let's get this correct. So far, gotta fix this. Okay, that's better. Now let's get these points are wrong. Okay, so let's fix that. So we need to go 3 down, 1 over. We should be there. 1 over, 3 down, 1 over. So I need to fix this a bit too. There, that's better. And let's extend that line then. Alright, there we go. So that is in terms of the new coordinate system. That is y equals, big Y equals capital equal, big Y equals 3 times capital X. Okay, again remember the slope is 3 here. It should be 3 to 1. Okay, so now in changing getting big X and big Y in terms of little x and little y, I look at this right here. So notice y doesn't change, so little y and big Y are the same. But to go from the old x to the new x, I have to subtract 5 from the old x. This is x minus 5. Okay, so in terms of the new coordinate system, this is capital Y equals 3x. But in terms of the old coordinate system, I should have put a y here. Y is going to be 3 times the quantity x minus 5. Okay, that's how we're going to write this. Okay, and you could multiply this out, but it won't. If you do that, it's not going to show the shift. But this also be 3x minus 15, meaning the y-intercept down here is going to be at negative 15. So g of x could be written as 3 quantity x minus 5. So while you can write as 3x minus 15, this reveals some information though too. It also happens to be the x-intercept in this case, but that shows your shift. Finally, we could write this simply as g of x is f of x minus 5. Okay, now why does that work? Because look at your original function, f of x equals 3x. So everywhere that there is an x here, I'm going to replace it with x minus 5. So this becomes 3 quantity x minus 5, which is what we had here, which then could be written as 3x minus 15. Alright, let's look at another example. Translate f of x equals negative 2x 4 units to the left. Alright, so here's our original origin at 0, 0, and we're going to move it here, the new origin is 0, 0, and this is the big X, big Y axis. This is the little x, little y axis. So we're going this way. So we're going to create a parallel line that's shifted 4 to the left. Let's draw that line in here. Except my mistake here is the slope is negative 2, not negative 1. So I'm going to go from here over 1 up 2, to the left 1 up 2, over 1 up 2, because it's a falling slope, it's negative. Let's get some points to make the graph easier to draw. So now let's go through those points. Alright. We'll also call this function. So this is, again, in terms of the new coordinate system, this is big Y equals negative 2x. And we'll call it g of x also as we get further into this problem. So now, notice to go from old to new for x, I have to add 4 to x. This will be big X, I'm sorry, little x, big X will be little x plus 4. Y does not change. So now here I make the substitution, big Y I replace with little y, and then I replace big X with quantity little x plus 4. So you could write this as y equals negative 2x minus 8. In this problem you can see there is your y-intercept right there, which is negative 8. Okay, so this does work, but the advantage of writing it this way is you can see the shift. There is a horizontal shift 4 to the left. Okay, so now g of x could be written as negative 2 quantity x plus 4, or it could be written as negative 2x minus 8, or you could write in terms of f. It would be f of x plus 4. And again, why does this work? Because everywhere in the original function I'm going to replace x with x plus 4, so g of x is negative 2 times quantity x plus 4, which is what we got here. If we multiply it out, we get negative 2x minus 8. Okay, stop the video. So I want you to translate the function f of x equals 1/2 x to 3 units to the right. Stop the video. So again, here is the original coordinate system. This is the original origin, 0, 0. This is going to be our new origin. Okay, I want you to give the coordinates in terms of the old system and the new. And then I want you to complete what I've got here. Let's also put in here little y equals blank. Okay? Or actually, no, you're going to do that because you're going to be replacing big Y with little y. Okay, so stop the video, work the problem, and see how you did. Okay, so let's fill in the information here. So in the old system, this is going to be 3, 0. In the new system, this is going to be 0, 0. And I should have written here, this is the big X, big Y axis, the new coordinate system. So now big X in terms of little x, I'm going from 3 to 0, so I have to subtract 3 from x. So that's going to be little x minus 3. Y doesn't change, so that's just going to be little y. So now replace big Y with little y, and replace x with the quantity x minus 3, which if you multiplied it out would be 1/2 x minus 3/2. Okay. In terms of g of x, we'll just write it as 1/2 quantity x minus 3 again, and then g of x also could be written as f of x minus 3, which then if you make the replacement into the original function, y equals 1/2 x, that's going to be g of x equals, everywhere there's an x and f, you replace it with x minus 3, which then would give you 1/2, like we had before, would give you 1/2 x minus 3/2. So this is just a different notation, but I want you to be aware of that. Okay, I almost forgot here to graph the function. So slope is a half. So this again is the function or the equation y equals big Y equals 1/2 big times big X. That's this here. So I'm going over 2 up 1 for the slope, over 2 up 1, over 2 up 1, because the slope is, it's in a ratio of 1 to 2, or vertical to horizontal. So let's draw that line. Okay. All right. So we have one more practice here, which is translate f of x equals -1/4 x 6 units to the left. So I've given you, here's the original origin, 0, 0. Here I want you to fill in the coordinates for the old, in terms of the old origin and the new origin with the new axes, capital X, capital Y, and sketch the function in, draw the function in. You're using your graph paper, of course, and your ruler and so forth, pencil, and then complete this information over here. Okay, so stop the video, work the problem, and turn on and see if you've done it as I did. Okay, so this is going to be -6, 0 in terms of the old coordinate system. It's going to be 0, 0 in terms of the new. So then this is the capital X, capital Y axis. Big X is going to have to be in terms of little x. Well, to get from -6 to 0, I have to add 6 to little x. So that's going to be big X, little x plus 6. And then there's no change in y. So that means big Y is going to be, well, I'm going to replace big Y with little y, and then I'm going to have -1/4, and I'm going to replace big X with quantity x plus 6. So this is the translated function. I don't have a lot of room there, so I could write this though. I'm going to write over here. So this could be written as y is -1/4 x using my distributive property minus 6/4, which is 3/2. So that's another way, that's a way to write the translated function. Let's draw that function in before we finish this out. So the slope is -1/4, so I go over 4 down 1. So I'm going to go 4 units over 1, 2, 3, 4 down 1. 4 units over 1, 2, 3, 4 down 1. 4 units over 1, 2, 3, 4 down 1. I could go back then 4 units and up 1. So now I have quite a few points. It helps it make it a lot easier to draw this function in this straight line. So it's going to look like that. Again, this is, in terms of new coordinate system, this is y, capital Y equals -1/4 times big X. Okay. In terms of the old coordinate system, little x, little y, again, we just did that. This is -1/4 times quantity x plus 6, or y equals -1/4 x minus 3/2. In terms of, if I use g of x to name this function, the new function, that'd be g of x is going to be -1/4 quantity x plus 6, or times quantity x plus 6, or g of x is f of x plus 6. But again, you could then expand that out again, because in the original function, -1/4 times x, I replace x with x plus 6, so I have -1/4 times quantity x plus 6, which shows the horizontal shift to the left. But if you multiply it out, you would get this, and you can see there is my y-intercept, which is -3/2. That's -1.5. So it all works out. Alright, let's summarize what I've done in this video. So in these exercises, I've been showing you how to shift the axes from little xy to capital XY. In reality, if you see a function, you don't have to go through all that. You just now should be able to recognize that, for example, here, if I have f of x equals x minus b, that tells you the function shifted b units to the right, which is the opposite of what you probably would have expected. That's what I tried to show in this video. So for example, f of x equals x minus 4, that function could be seen as shifted. The original function is, the parent function f of x equals x is shifted b units to the right. So if I have f of x equals x plus b, this would be shifted b units to the left. For example, f of x equals x plus 11. F of x equals a quantity x minus b, that's a slope of a, that would be shifted b units right. For example, f of x equals 3 times quantity x minus 2, that would be a function with a slope of 3 shifted 2 units to the right from the function f of x equals 3x. So if I have f of x equals a times quantity x plus b, that would be shifted b units to the left, and let's put in an example here. I guess I didn't do that. So that an example here could be f of x equals, say, 4 times x plus 1, quantity x plus 1. So that would be a shift 1 left of the function f of x equals 4x, which would have a slope of 4. So if I have g of x equals f of x minus b, we're shifting the function f b units to the right. Example, f of x equals, example, g of x equals f of x minus 8. This would be the function, g of x would be the function f shifted 8 units to the right. And then g of x equals f of x plus b. That would be shifted b units left. So an example here would be g of x equals f of x plus 5. So g would be the function f shifted 5 units to the left. Okay, this concludes the video. I hope it was helpful.